Alright, chemistry dudes, here's the deal. I got two problems, two examples here, showing you an acid first, given a concentration, and the next slide is going to have a base, given a concentration. And from those concentrations, you're responsible for calculating the pH, the POH, the H plus ion concentration, and the OH minus concentration. So here's the deal, dudes. You want to first, if you can, practice these and try these, and then see if you get the problems right. Right. Here's how I'm going to start explaining this. H2SO4 is sulfuric acid. And the first thing I want you to note is that it is polyprotic. And when this acid dissociates or ionizes, more specifically, it's going to produce 2H plus ions. An acid is a substance that contributes hydrogen ions or protons into solution. This one donates 2 when it dissociates. It's considered a strong acid. So the first thing we're going to do is address the quantity or the number of H ions in solution. Now right now I see that the acid has a concentration of 5.7 times 10 to the 7th molarity. Well, when it dissociates, it's going to produce twice as many hydrogen ions. So by a simple multiplication times 2, I end up finding out that H2SO4 will produce 1.14 times 10 to the negative 9th hydrogen ions. And I'm going to label that down here, 1.14 times 10 to the negative 9th H plus ions. And that's molarity. That is the concentration of my solution. Alright, dudes. Well, my solution has that concentration. The next question is, where am I going to go with that? What can I use? Well, if that was my first step, the second thing I would do now is calculate the pH. Because the pH is going to be the negative log of the H plus ion. And in this case, I've just solved for the ion. So I'm going to substitute that in there. The pH is the negative log of my H plus ion, which is 1.14 times 10 to the negative 9th. When I crunch the numbers, dudes, I end up finding out that this solution has a pH of 8.94-ish. Now, I'm using the numbers that I have here. And if you're entering them in your calculator and they're different than the numbers I am using, then you will get a different number. Because I'm going at 2 decimal places here. So now I've calculated out the pH is 8.94. The next thing I would do is use the formula pH plus POH equals 14. Now when I substitute 8.94 plus POH equals 14, I can solve for the POH to be equal to 5.06. Now if you're getting a number like 5.1 or 5, like you're in the ballpark, that's okay, guys. You're doing a great job. The last thing we need to do is now solve for the OH concentration. And I'm going to use the inverse log function. You're going to look for the number that's directly above your log button, where it says, you see log on your calculator, you should see a button that says log. And then above it, you should see 10 to the x. We're going to be using that 10 to the x button. And you need to plug the numbers in like this. 10 to the x is going to be equal to my OH concentration. But the thing is that over here, I want you to see, I use the negative log. And we need to account for that. So I'm going to do 10 to the negative POH is going to be equal to my OH ion concentration. And when I substitute in 10 to the negative 5.06, I find out that the OH concentration is going to be 8.70, using my numbers, times 10 to the negative 6 molar. Alright, dudes, that is where I'm going with this. It's a 4-step process. First step, double my concentration of my acid, because I had a polyprotic acid producing 2 H's. Once I did that, I substituted that number into the H plus ion concentration and found the negative log of that and got my pH of 8.94. A quick little calculation of pH plus OH equals 14 gives me a POH of 5.06. And lastly, I'm going to substitute that POH value into my inverse log function and use a negative POH to work backwards and find out that I had an OH concentration of 8.70 times 10 to the negative 6th. Alright, dudes, that was what happens for an acid, but I have a magnesium hydroxide, it really should be a magnesium hydroxide solution, has a concentration of 3 times 10 to the negative 5th molar. Now, in this case, when this dissociates, I do not produce any H pluses. So I want you to see that right off the bat. When this dissociates, I'm going to produce OH minus ions, specifically 2 of them. So just like we saw in the last slide, my OH concentration is going to be equal to the molarity of my magnesium hydroxide, which is a base. So I'm going to use 3 times 10 to the negative 5 times 2, because I have a 2 right here for 2 hydroxides produced. So when I do that, I end up finding out that my hydroxide concentration is 6 times 10 to the negative 5th molar. And I'm going to throw that down here right away, 6 times 10 to the negative 5th molar. Now that I have the hydroxide concentration, that was step 1. Step 2 for me most likely is going to be solving for the POH, because the POH equals the negative log of the OH ion concentration. Let's throw in a substitution here. So you have POH equals the negative log of the OH concentration, which is now 6 times 10 to the negative 5th, because we doubled the ions, and we end up finding out that my POH is equal to 4.22. And I'm going to plug that in over here. Now, if you got 4.2 or just 4, you're ballpark with me. That's a legit answer, guys. I'm down with that. Step number 3, I'm going to use the good old classic formula, pH plus POH equals 14. A little substitution here, pH plus 4.22 is going to equal 14. And now I find out that my pH is going to be equal to 9.78. I have a basic solution is what I have here. So my pH is 9.78. Now lastly, dudes, let's get the hydrogen ion concentration. There's actually more than one way to solve this, but I'm going to give you what I think is the easiest. Step 4, I'm going to use the inverse log function. Same way as last time, I need to find the log button and get to the 10 to the x button above there. It's often a shift. So I'm going to enter in 10 to the negative pH is going to be equal to my H plus ion concentration. A little substitution goes a long way. 10 to the negative 9.78 is going to equal my H ion concentration. And my H ion concentration ends up being equal to 1.66 times 10 to the negative 10th. And that's going to be molar. Now here's the deal, dudes. Your numbers should be close to mine. I went out to 2 decimal points. Now if you went out to 1 or none, your numbers are going to be somewhat in the ballpark. Somewhat. Definitely not exactly. So what you have here now are 2 examples when I give you the concentration of an acid or a concentration of a base and how to get the rest of these from that. Alright, dudes. I hope it was helpful. Best wishes on tomorrow's test. Peace.